earlier we were doing a demonstration called the iodine clock reaction, which is pretty interesting because it's a reaction that has a delay in it, and then all of a sudden there's a color change after a very particular amount of time. We're going to take that up a notch today and do something called an oscillating reaction. It's like a clock reaction, but it cycles back and forth through several different colors a whole bunch of times. It may do it for 20 times it'll cycle through. I won't tell you the colors yet, I'll let you be surprised by that. There's quite a few chemicals that need to go in here. I have 4 solutions with a lot of different things in them. So let's begin by adding our first 2 solutions. We need to let them mix and react for a minute or 2. So we're going to put those in here. Now let's turn on our stirrer, get that stirring very nicely. We'll let that mix for a minute or so. So we'll take a short break here from the filming, let these chemicals mix for a moment, then we'll come back and add the other 2. All right, I think we've let these 2 mix long enough, so let's add our other 2 substances. This nice orange chemical contains the element cerium, which gives it that lovely color. Sort of a beautiful red-orange color now. And then we're going to add an indicator. This is going to help us see all the different colors. So let's go ahead and put this in. Now usually when you add that indicator, it looks a little cruddy. It sort of looks like some kind of swamp water here. But let's give it a minute or so, and it's going to clear up, and then we're going to begin to see the oscillation. So we'll just give that a moment here, and then we'll begin to see the color changes. Looks like the reaction's just about ready to begin. All of that cloudiness has disappeared, and now the colors are going to begin. It started out as a lovely green color. And usually the oscillation takes about a minute, maybe just over a minute to go through the cycle. Now the green has become blue. Sort of like the rainbow color demonstration we did earlier in the semester. So let's keep an eye on that blue and see what happens here. Right, it looks like it's beginning to move into the violet range. We're sort of moving through the rainbow here. Blue, indigo, or green, blue, indigo. Here comes violet. And once we get to violet, we're the end of the visible spectrum. Roy G. Biv, I think we should cycle right back to R again at the beginning of Roy, and there we go. It's becoming a nice red color again. So we don't get every color of the rainbow, but quite a few. We're going to get red, green, blue, indigo, and violet all in one reaction this time. So once it gets to this sort of rusty red color, it's all of a sudden then going to cycle back through and start once again. Should be happening. Oh, here we go. You get a flash of blue, and then we're back to green again, and now it's going to cycle back through all of those colors. So we should have our green, and then our blue. There comes the blue here. And before we know it, we should be getting our indigo and violet, and then we'll finish up with red once again. So why don't we let this run for a bit? I'm going to step back, and we'll zoom in on this so you can see it a little better, and maybe we'll speed up the recording a bit so you don't have to wait a minute and 10 seconds or so for every one of these things to cycle through. We'll let it run through a few cycles so you can see what's happening. I've increased the speed of the playback now to 5 times normal so we can run through a few cycles fairly quickly. I've been timing this all day. I've been doing this more than one time, and it's amazing how accurate the time is. It's been taking just about exactly 1 minute and 10 seconds. So I've got my stopwatch ready here. As soon as that changes, let's begin timing one cycle here and see how close it is to that 1 minute and 10 seconds. There we go. We'll start the timer here. And when it gets close, I'll do a little countdown. You guys probably can't see my timer there, but we're up to 10 seconds now, so it should be about another minute, and we should suddenly get back to that red color again. All right, we're getting there. So about another 40 seconds or so, we should finish the cycle and then revert back to that initial blue color again. There's 40 seconds. Should be about another 25. When we get up to a minute, I'll start counting it for you here, and we'll see how close it is to that 1 minute and 10 seconds when we cycle back to the beginning again. Getting close. 1 minute and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 minute, 10 seconds. Right on the nose. It's a pretty amazing reaction. Chemistry is actually a very predictable type of thing. We can predict what's going to happen in chemical reactions. It's something called kinetics, which if you are taking general chemistry and you get to the second semester, you will learn all about that. Let's go ahead and watch a few more cycles of this then.
Why are there so many songs about rainbows? And what's on the other side? Rainbows are visions, but only illusions. And rainbows have nothing to hide. So we've been told, and some choose to believe it. I know they're wrong, wait and see. Someday we'll find it, the rainbow connection, the lovers, the dreamers, and me. Who said that every wish would be heard and answered when wished on the morning star? Somebody thought of that, and someone believed it. Look what it's done so far. What's so amazing that keeps us stargazing? And what do we think we might see? Someday we'll find it, the rainbow connection, the lovers, the dreamers, and me. All of us under its spell. We know that it's probably magic. Have you been half asleep? And have you heard voices? I've heard them calling my name. Is this the sweet sound that calls the young sailors? The voice might be one and the same. I've heard it too many times to ignore it. It's something that I'm supposed to be. Someday we'll find it, the rainbow connection, the lovers, the dreamers, and me.